In this section, we want to discuss the very important and very useful topic of radians. And radians are another measure of angle in the same way that degrees measure angle. You probably are familiar with the fact that a circle has 360 degrees. Radians are a nice unit of measurement of an angle because all they involve is the ratio, the natural ratio between the arc length of what's called an intercepted arc. So if I have this chunk of a circle represented by an angle we'll call theta, and my arc out here we'll call from this point to this point, we're going to call that arc length S. And here we have two radii of the circle. So the if we define theta as being the ratio of the arc length S to the radius R, that's going to allow us to use a measurement called radians. And it's simply just a ratio because both of these are measuring distance, so the units are going to cancel out. And you have a circle which you know has 360 degrees. Um, it turns out that if you were to measure the arc length or the circumference around the entire circle, you're going to get a ratio of the circumference to the radius being 2 pi. And you may be familiar with the equation that represents that. Circumference is equal to 2 pi times r. So we're talking, if this 2 pi was my angle, the arc length ratio to the radius is going to be 2 pi. So in other words, c over r equals 2 pi. Everything else, every other angle within that circle is going to be some other ratio of this arc length to the radius. So um, because we do have a full circle that has 2 pi radians, 360 degrees is the equivalent of 2 pi radians. And we could even simplify that. If we divide both of these values by 2, we could know that a half a circle, or 180 degrees, is equal to pi radians. And that will be a useful conversion factor to us to convert from radians to degrees. So when we do want to uh, convert from radians to degrees, we're going to take our radians value and we're going to multiply it by 180 degrees over pi radians. So that this gets us from radians into degrees. If we want to go from degrees into radians, we're going to take pi, that number times pi radians divided by 180 degrees. So let's look at a couple examples that'll show that. So here we're instructed to write 135 degrees in radians. So as I said, we'll take 135 degrees and multiply it by pi radians divided by 180 degrees so that our degrees cancel out. So if I take 135 times pi and divide by 180, I get 2.356. But that's essentially, they want us to write it as a multiple of pi. So I could say that there's 2.356 radians in 135 degrees, but instead I'm just going to go ahead and write this out as an exact value, 135 pi over 180. And let's simplify the 135 over 180. Let's see, if we divide both by 5, we get 27 pi over 36. And we can now divide top and bottom by 9, and that's going to give us 3 pi over 4. And again, if you did want to approximate that, they weren't asking you to write it as a multiple of 5, you could say 2.36. So for the second example, we're asked to do the same thing, convert negative 30 degrees to radians. So we use that same conversion factor, pi radians over 180 degrees. That's going to give me negative 30 pi over 180. You can see that we can cross these zeros out and make it negative 3 pi over 18. Both are divisible by 3, so we can make that negative pi over 6. If you wanted to approximate that, that is about 0.52 radians. So now we're given the reverse. We're tasked to write 2 pi over 3 radians. Notice there's no unit there. Radians is kind of implied because it's just a ratio. But 2 pi over 3 radians to degrees would be 2 pi over 3 times 180 degrees over pi radians. So my pi's are actually going to cancel out, and I'm going to get 360 over 3 degrees, which is the equivalent of 120 degrees. Finally, we have this expression, negative 3 pi over 4 radians that we want to put into degrees. So let's multiply by 180, divide by pi, put the degrees in there. Pi's cancel out. 3 times 180 is 540, so we get negative 540 over 4, which simplifies to negative 135 degrees. Sorry if there's a little cut in there, I got interrupted. But just one more to try out. See if you can figure out what 150 degrees would be in radians.